Hey, this is Justin, and welcome to Lesser Dog Tutorials. This is part 9 in the adventure game, point and click adventure game tutorial series for Unreal Pixel Perfection. So, the past few weeks, I've been working on the dialogue system, and it is all complete. I just need to actually record the videos and then edit them. But while working on that dialogue system and having two characters talk, their bark text was popping up above their heads, and I just kept getting um, errors, little visual errors. So I decided to figure out how to make it look much more pixel perfect, and that's what most of this video is going to be. Just at the beginning, we're going to clean up some stuff and really prepare it and get this project ready for the dialogue system, which will be coming next. So let's get started. So the first thing we're going to do is replace every string variable in our project with a text variable instead. This is because text is actually much better and user-friendly, and it can be localized if you wanted to have your game be in different languages. So the first one we're going to change is the widget blueprint bark text in the function setBarkText. The input pin was a string. We're going to change that to text. Then we could just clean things up a bit. Then we have to go to the adventure character, the player bark function, and you can see the player bark input also had a string. So switch that to text and relink these two nodes. Now if I find references to this function, here's one on the adventure controller where the task bark takes in a string, but we'll just change that to a text. And then we have this string variable called text to bark. We can change that to a text. And then it is being called in two locations. That would be on the adventure controller in combine inventory. We can change that input variable to a text and relink that up. And then over there in the player bark, that needs to be relinked. So the hotspot and the item blueprints both have a bark function that need to have the string changed to a text. So switch it in both and compile, and you'll see a bunch of new warnings. Over in the hotspot, we can just link up to the errors here, and they're all on the event graph. And so what we'll be doing in this event graph is just copying each text that we typed in the old string input and just pasting that into the text input. And then once you're done copying and pasting these, you just need to right click them and say refresh node, but you can select multiples to make it faster. So if you just shift click, shift drag a box over everything, and then right click one of them and just say refresh nodes, everything should be updated. And so you can see here the bark text, there's a drop down that can say, localizable, package, namespace. It can have a string table, just a whole bunch of stuff the text can do the string really can't do. So if you compile, you'll see we got one more warning down here, and that's in the item use failed. So we'll just do the thing where we copy, paste, and refresh. And then over in the item blueprint, in the event graph, it's the same deal. There's a lot of nodes that have a bark text input, and we just want to copy and paste and then refresh. Cool. Now we can compile that, and there's two errors. And over here in the item combined fail, we got to change that input to a text. And then in the event graph for the item, we just need to refresh that node. All right. So if we go to the hotspots and just go down the list of these hotspot blueprints, make sure that there's nothing in there that's screwy. Okay, so the poster has a few. Just copy and paste and refresh. All right, no errors there. Next one's the pickup. There's nothing there. Next one is the pickup knife. We have one node here, looks like. No errors there. And then the locked door has one. That's good. And now over in the item pickle, there's one in the item combined success function. And the same thing with the knife item combined success function. Next, we'll go to the widget folder and open up the interaction blueprint. And in the set text function, we have to change the input there to be text. And then in the HUD, we're going to have a ton of errors. Now, what's different about this, about text versus string, is that we're not going to be using this append node. We'll be using something that I'll show you in a bit. The first thing that we want to do is the variables. There's 2 string variables. Let's switch those to text. And we'll change the interaction string name to interaction text. If you just drag the active verb string to the interaction string variable, it will just switch it to text immediately. And the interaction string is screwed up. It just needs to be replaced. And I'll do that in a bit because it really should be saying interaction text. So in the set hotspot function, you can see the hotspot description is a string from the hotspot. So we need to head over to that hotspot blueprint and change that. I'm going to close some tabs real quick, but here the variable, you see the hotspot description, change that to text and compile that. And now you can unhook the string connection and unhook all these and just delete that append node. So now from the string, we can say to text to convert it to what we need. But the function that we're looking for is called format text. And all it has, it's a very simple node. It just has an input pin called format and a result. And whatever you type in this format box, you can make into a string. However, in order to add additional pins, you just surround some word or number with curly brackets. So in this example, I just have a 1 surrounded by curly brackets and a 2 surrounded by curly brackets, and it shows both of those input pins. So if you hook it up right, so the hotspot description's on the bottom and the active verb's on the top, we can rename the 1 to active verb, and it will show in the input pin there. And then on the second one, we could say hotspot description and have a space in between both. And now it's stringing these 2 texts together to create a sentence. So now if we open the preposition check function and then the add preposition, we can kind of update some of this stuff here, and we can copy and paste these prepositions that we typed into the new text input, but we don't need a space on either side because we can add a space when we format the text using that node from earlier. And I think I'm going to change the on to with. So inside the add preposition, we're going to remove all of this append node here because it's not needed. Instead, we're going to bring back in our friend format text, and we'll just type in how we want the text to look. So in brackets, I'll put interaction string, and then after the bracket, I'll put a space, and then I'll put new brackets, and I'll say current preposition, and then another space, and then hotspot description in a third set of curly brackets. And now you can see all of the input pins have shown up, and we have created our sentence. So now I'm just going to organize this a bit. And you can just go through and update this entire function by doing the same stuff that we've been doing. However, now I notice that the inventory item description is still a string, so head over to the item blueprint, and we'll change that variable to be a text instead of a string. And then we can continue doing what we need to do. So over in the set inventory text function, we got a couple of pins here that we can get rid of. From the active verb, we can select the to text node. And then from the description, we can pull out and This is where we will add a little reroute node, and then from that, we'll do that format text, but we can't hook it to the first pin. So we will just type in look at, and then a space, and then in brackets, we'll just say description. And the result will go up to that set text node at the top there. And now we need the description again to do another format text node. But instead of look at, we'll just put in the active verb input with a space between it and the description. But you will notice they are ordered incorrectly, but it doesn't matter because the format is all that's important. So make sure that the active verb is in the active verb input and the description is in the description input, no matter where they are. Now, there is an issue with this interaction string because we had named it interaction text. So we will need to replace, anytime this interaction string is out there, we need to replace it with our interaction text, and dragging over it won't work. So you just need to replace it the old-fashioned way. You'll see it pop up in several other locations too. In the preposition check function, in the add preposition, you can see the interaction string is right there. That needs replaced. Same with here at the beginning. And then looks like set hotspot text has an issue. So we'll set that. And then in the set interaction text function, replace that one too. And I think that is all we need to do in our replacing the string saga. Now that that is out of the way, let's do one more fun little thing before we get into the pixel perfection. And if you look at the bark length, we have the time of 3 every time the player barks in the adventure character event graph. It would be cool to be able to have a function that changes the length of this timeline based on how much text the character is barking. Well, let's do it. Open up the adventure library, and we're going to create a function in here that we're going to call getBarkTime. So first, let's add a variable, a local variable, that's going to be called short. And this is just going to be of a type float. And if you compile, we can set the default value to something like 1.5. And then we can make another variable that will be called medium. And the time for that could be 2. And then we'll create another one that we'll call long. And we could say that this one would be maybe 3. And then maybe one more. And we could say that this one's called extra long. And we can make that 3.5. And all of this is just whatever you want. Whatever you want to say is a short time or medium or long or whatever. So now we just need to decide how to use this function. So in the adventure character event graph, move up this bark section a little bit, and we'll add a custom event underneath, and we'll call it bark time. And then if we right click, we're actually able to get the bark timeline that exists right in this event graph. And from this reference, we can actually set the timeline length at will. So if we hook that up to the bark time, we just need to determine what the length is. So in the bark time event, we could add an input of a type float and just call that bark time. And we'll hook that up to the new length of the set timeline length node. So now, in order to trigger this, we should go to the player bark function on the adventure character. And right at the end here, right after the set bark text, we can run that bark time. We'll just need to determine in this function how much time we're going to be waiting, because at the end we'll run that bark delay, which will run the bark timeline, which will be set to whatever time we say. So we need to go back to the adventure library, and we'll add the return node, And we'll add a return node output pin of the type float that we'll just call bark time. And if you make this function pure, like the other getters we have, and compile and save, we can head over to that adventure character blueprint and call get bark time from our adventure library and hook that up to the bark time node. However, we need to take in this text here into this get bark time. So if we add an input pin of type text, we can call this bark text and then connect that node up to the reroute node there. And now we are running the function. We just have to find out the logic, and it will actually set the timeline length to whatever we want. So it's just going to be a series of branches, really. So the first thing we want to do is get the length of the text. In order to do that, we need to convert it to a string. And then from the string, we can get the length. And so now that we have the amount of characters in the Spark text, we can create another variable that we're going to call text length. And we'll set that to an integer. And we could set this right at the beginning to the length of the Spark text. Now we'll just need to compare this variable to different amounts to determine if we should return short, medium, long, or extra long. So from the text length here, we can just compare by doing a less than node. And we'll say maybe if it's less than 15, then we'll add that branch. And if that's true, then we'll use the short time that we've made. So we'll just need to make another variable. So we'll just call this something like time to wait and make sure that it is a float. And we will return the time to wait at the end here. And we'll just set whatever time to wait is based on the other variables that we made. So if this first branch is true, then time to wait will be set to the short time that we made. And we could just run this straight to the return node because it will not be doing anything else. And then if we look at this branch again, and if it's false, it's greater than 15, then we're going to compare it to something a little higher, like 30. So if it's less than 30, we'll branch. So if it's greater than 15 but less than 30, and if that's true, we'll set the time to wait to be the medium variable that we did earlier. And then, of course, that's going to leave immediately. Then we can do one more branch to test to see how long the text length is. And if it's less than, say, 60, we'll branch from that. So if it's greater than 30, less than 60, then we're going to set time to wait to be the long length. And if it's false, we're setting the time to wait to be extra long. And then both of these will return. And there you have it. Now text will show on screen for the amount of time that seems appropriate depending on the length of the bark. With that out of the way, let's get into pixel perfection. So the first thing I want to do is import the grid, which is a part of the assets in the description. And when you apply the Sprite Paper 2D settings, then you can head over to the HUD, and we'll add an image to the overlay so that it's at the bottom of the list, and then stretch it out over everything, find that grid and apply that image, and then make sure you set the visibility to not hit testable self only. And now if you play, you can see a grid, and it will help you kind of understand if things are actually pixel perfect or not. And so our goal is to kind of use this as a tool to help us know that things are aligning correctly. All right, to start things off, we are going to create a canvas render target, and that is under materials and textures, and it's near the top here. So if you click that, we'll rename it to CRT underscore game view. And if you open that up, you'll see that you can set the size X and Y to specific dimensions. So let's set X to 320 and Y to 144. Then at the texture group dropdown, switch it to 2D pixels unfiltered and then save that. Now you can right click the texture, create material, and we'll just call this M underscore game view CRT. And then if you open that up, we can change the material domain to user interface and relink the RGB to the final color. And that should be all we need to do in this, so go ahead and save that. Next, we need to open our Adventure Cam. And what we'll do is select the camera and then add a component. And we're going to add Scene Capture Component 2D. And so it should have the same dimensions and rotation and all that of the camera. But we're just going to change the projection type to orthographic, the ortho width to 320, and the texture target down here to the CRT game view. And now the Scene Capture 2D is going to be projecting what it sees onto this texture. So if you turn on the tower exterior, you can see that it updates, and now we see the level. Now switch over to the HUD blueprint, and what we'll do is add an image to the overlay so that a new image appears under the grid. Now select the grid, and we're going to change the opacity down to 0 just so we don't see it anymore. And then select that new image, and we'll rename it to Game View. And then you can right click it, wrap it with a size box. And then we'll change the size to the texture. So it would be 320 width and 144 height. And then we can just align it to the top, and you can center the horizontal alignment. And then lastly, we will select the actual game view image and change the image to the material that we made called M underscore game view CRT. So what's happening now is that the Scene Capture 2D is projecting the scene onto this image at a very low resolution, 320 by 144, which would make it pixel perfect, and I'll show you in a bit. But right now, since we're in here, let's fix some of these dimensions because they are incorrect. So select that black screen image and change the height to 144. Now you can select the drop down, the vertical box drop down, open that up, and select that first size box and make that 144 also. Now it moves the bottom section up a bit, so select the next size box and change the height to 56. Also, make sure before you leave that you have the game view selected and switch the visibility to not hit testable self only. So we can compile and save that. We'll come back in here and fix it up a little bit more in a second. So back in the Adventure Cam, we want to select that camera and change the ortho far clip plane to 1. We don't want this camera seeing anything, but we still want it to move and follow the player. So it'll be in here as a dummy camera when really the Scene Capture 2D is going to be doing the camera's visual work. So, in the event tick, the camera is going to be following the player, lerping within the confines, and then setting its position. But since the Scene Capture 2D is a child of the camera, it will move with the camera everywhere it goes. So let's test it out. All right, so you can notice things are a lot more jagged and crisp. That's because everything is at the lowest resolution possible, and all movement is aligned with the pixel grid. So we could turn on the grid just to demonstrate, but the grid will need to be behind everything. So let's move that size box right above the black screen, and we'll rename it to Game. And so now the grid can be turned up, the opacity can be turned up to 1, and we can compile and save and hit play. And if you watch as you move around and you look at the background, everything should be lining up to the red grid that we made, which is great. This is pixel perfect. The visuals are pixel perfect. However, the only issue is going to be anything UI related, so things that the camera won't see. So let's get some of this figured out. First thing I'm going to do is reduce the opacity on the grid again so that can be hidden. And then I'm going to go to the fonts folder and I'm going to delete all of these fonts, even though they're being used by a couple of widgets. And then from the assets in the description, I'm going to re-import the fonts and we're going to relink them up. So if you open up the interaction, we can select the text and we'll relink it to the new font, but we'll change the size to 9. I did some fixing on these fonts. Now on the top padding, we'll do -1, and the shadow offset will switch back to 0. And that's all we need to do in here. As you can see, there is a pixel space above and below, and that's what we're looking for. So now open up the Bark text widget, and we'll replace these texts. So the top one is the BG, and the bottom one is the outline font. And then we want to change the size of the text to 9 for both of these. Then we can select that size box, and we'll change it to 260 width and 33 height. And we can compile and save that. Next, I'm going to right-click the Bark text file and duplicate it. And I'm going to name this one Bark Line. And if we open up Bark text again, we can delete the text in here. We won't need it. And the overlay we will replace with a vertical box. And we can rename this box Bark Line Holder. And then we can wrap the size box in a scale box. And then head over to the graph, and we're just going to delete the function set bark text because this is not going to be the same widget as before. And then we can open up the Bark Line widget. And what this is going to be is essentially just one line of text. So we can select that size box, and we'll just change it to 11 on the height. And then we'll want to wrap the overlay with a vertical box. And we can rename the vertical box to text pad box. Next, we want to select both of the text objects and make sure that the shadow offset is set to 0. Now, if you select the text pad box, we can change the padding, and we're just going to change the top to -1. So it's aligned to the top, but we still have some space on the bottom. Switching over to the Bark text again, we can drag in one of our Bark lines, and we can see that it's aligned to the top. So select that holder and align it to the bottom. And now what this holder is going to do is just take in 3 total lines, or I guess more if you want, but we want to separate each line up because it helps us kind of align things to the grid a little better. And you'll see that a little more as we continue. Now in the designer section of the HUD, if we open up that size box that has the game area image, we can delete that because what we're going to be using instead of an image is an overlay. So if you drag that overlay into the size box and then you center the horizontal and vertical alignment, we can now drag the user-created widget of Bark text over top. And if that's centered, that's really all we need. So we'll rename it to Bark, and we'll make sure it is a variable. And compile and save. Now over in the Bark text event graph, we can delete all the nodes that are there, and we'll add a custom event that we're going to call set bark text. And then if you look at the adventure character where we're referencing a function called set bark text, there's an error because there's no input for the text. So we can add that input here, and we can just call it bark text. However, I didn't compile it, which is going to create some issues. So when you link it up, there's an error because it can't find the term bark text because I didn't compile after I named it. So if you refresh the node, it'll show that it says new parameter. I will fix this a little later. Hindsight's 2020. So you can connect it up to the new param input, and then over in the event graph on the adventure character, there's an error again. If you refresh, it'll show new param as the name. And then in the clear bark function, again, I refresh the node there. So back in the event graph where the set bark text is on the bark text widget, we're going to look for a node called create widget, and we're going to select the bark line widget, and we'll hook that straight up. And then after that, with the return value, we're going to set the bark text, and we'll link that up to the bark text input on the event. Next, we need to add this to the holder. So as long as we make sure that that holder is a variable, we can now drag in that holder and we'll add the child and we'll select that return value and link that up so that it now adds the bark line to the bark line holder here in the bark text widget. All right, with that compiled, now we can switch back over to our player bark function on the adventure character and relink that set bark text. But also we need to get the HUD and get that reference to the bark text widget we added, because that is where the bark text is going to need to be set and not on the user widget of the bark text. So I also reconfigured the HUD. So now we have the scale box, the size box, and then an overlay. And the overlay is stretched horizontal and vertically. And under that we have a vertical box, again stretched to fill. And below that the grid. And the grid is also stretched to fill. If you open up the vertical box, we have two more size boxes. One is called Game, and it's set to 320 by 144. And under that, we have an overlay, again, set this to fill, horizontal and vertical. And in that overlay, we have the Game View object with the image and the material. And then under that, we have that bark widget, and the bark widget should be centered on the screen there. And then under that, we have the black screen that will be used for loading rooms. And again, that will be stretched to fill. The other size box is called UI. And that size is 320 by 56. Under that, we have the UI area overlay, again, stretched to fill. And then inside that overlay, we have that BG, background image, which is stretched to fill. And then the vertical box, which contains the stuff from before, the interaction, and then the horizontal box and all the UI elements from before. So now if we play the game and we test out what we made and we use that poster, the text will appear in the bark text on the HUD. And that's what we're looking for, and that's going to be the element where bark text will always appear. And if you add another line, it will show that it goes underneath and pushes the old one up. And that's exactly the functionality that we're looking for in order to make this pixel perfect. However, if you notice and you look closely, you can see every pixel is offset by 0.5 for the text. Otherwise, it appears to be aligned to the pixel grid. It's just a little bit offset. So back in the character blueprint, we can delete that widget reference. We can delete the actual bark widget component itself. And then you see a couple errors pop up. We can delete the nodes at the begin play. And the clear bark function, we can delete that cast. And we're going to create on the HUD a function that we're going to call clear bark. And then we'll make another function called add bark. And for the clear bark, we can just drag in that bark reference. But we need to call something on the bark text in order to clear this. So if we create a custom event on the bark text event graph, we'll call that clear bark. Then we can drag in that bark line holder. And then from that, we can clear children, which will remove all of the bark lines that we add to the bark text. So as long as we call this from the HUD, drag out from the bark and find a clear bark. And then while we're here, we can open up the add bark function. And what we'll do here is just add an input parameter of type text. And we'll say that this is called bark text. And we'll add another input parameter. We'll call this bark color and change that type to color. Then we will add a third parameter, and it will be of the type sphere collision. And we will call this bark position. This is so we can have a reference to something that the bark text can move with, like, for instance, the adventure character. Now we'll create a variable called a bark position of the type sphere collision so that we can set this immediately. So now we have a reference to that position. Then we'll create a new variable, and we'll call this bark active, and we'll make that a Boolean. And then we can set it to true right after we assign that bark position sphere collision. If you compile and save, we can head back to the bark text. And what we'll do here is add a variable, and it will be called bark color, and we set it to that color struct. And then back in the HUD, we can take that bark reference, and from it we will set the bark color. and it will be equal to the bark color that we're passing into this function. Now that that's done, we can drag out from the bark, and we will set the bark text, and the text will be referencing the parameter that is being passed in. Now, if you compile and save, we can head over to the adventure character, and on the clear bark function, we can get the HUD, and from that, run the clear bark function. We can also delete the isBarking bool. We do not need that here. Now, in the adventure character, we want to head over to the player bark function, and the setting of the bark is actually going to be changed to add bark. And then we want to pass in the bark text. And then for the other two, we need to specify the color and the position of sphere collision. So let's add a variable for the color and change the type to that color struct. And we can assign that to by compiling it, and we'll just set it to the alpha to 1, and we'll keep it white because this is the main character and his color will be normal. So now we need the bark position. So if we go to the viewport, we can set it to the top, and we'll add a sphere collision, and we'll call it bark position. And then we'll set the sphere radius to 4, and we'll move it up to somewhere like -75.5. Then we can go back to the player bark function and make sure everything is hooked up, the color and the bark position and the text. Now that that is hooked up and everything seems to be operating correctly, we should head to the event graph for the HUD, and we're going to move all of the nodes on tick out a bit. We'll drag in that bark active bool, and we'll see if it's true using a branch. And we're just going to make the text follow the sphere collision. So if it's false, meaning the bark is not active, it continues on. Otherwise, we're going to get that bark position, we're going to get the socket location, and then we'll do a vector minus vector, because what we want to do is subtract from it the camera's position so that we just have a screen position of where the text should be. So if we go over to the adventure library, blueprint library, we can add a new function that we'll call getCamLocation, and we'll make it pure. And inside this, we're going to get all actors of class, and we'll select our camera class, BP Adventure Cam. And the out actors will just get the first element in the array because there's only ever going to be one camera. And then from that, we'll get that camera, and then we'll get the world location, and we'll add that return node and pass that return value into it. And we can rename this vector something like cam location. And if we compile and save, we can head back to the HUD and get that cam location and just drag it right in there. So we're subtracting the cam location from the bark position's socket location. Now, if you look over in the HUD, you see this bark. We're moving this bark's transform. We're going to move the transform on the X and Y from 0 all the way up to like 30 or -30. So it's a small movement. And that's what we're getting here. If we're subtracting the cam location, we're only getting kind of that number. So what we want to do is drag in that bark because we need to get that transform. So we set the render transform and then connect that to the true of the branch. And then we'll split that in transform struct so that we can get the translation, the scale, and the shear. Because all we're going to be messing with is the translation and not the rest of them. So let's go ahead and connect the set render transform out to the isValid line. And then we'll split the struct pin of this subtract node, and we'll make a vector 2D using the X and Y components. And then we'll connect that to the in transform translation. And then if we play and we use the poster, he'll say, I can't use that, and it will be following the sphere collision on the adventure character, which is what we want. However, it is moving a little smoothly. So back in the HUD, we're going to round the X and Y, And then from that, we can connect it straight to the make vector 2D, and it should align everything to the grid. Yeah, so it is moving in a little more of a choppy pattern, which is correct if it were to be a pixel perfect game. However, it looks like things might be a little off in their alignment. So if we turn that grid's opacity up again, we can test it out again and kind of see what we're looking at. All right, so I paused it, and you can see here that it's a little blurry, but you can see that there is a problem with the alignment of the text. It's set directly in the middle. So if we go back to the event graph for the HUD, we can add 0.5 to both of these results, and we'll see how that looks. So if we compile and save and try that out again, then it does appear that everything is aligned correctly. However, there is one thing that I want you to see. So if I were to use this pickle on the poster and we zoom in, you can see now that the text on the x-axis is in the middle of a pixel instead of being aligned correctly. It only does this when the length of the line in pixels is an odd number. So the reason I'm dividing bark text into 3 separate bark lines is because I want to be able to measure the width of the bark line, of each bark line, and if it's an odd number, I want to be able to pad it on the left side to become pixel perfect. So next, why don't we go ahead and open the set bark text function in the bark line widget blueprint, and we'll add a color input parameter, and we'll call it bark color. And then we'll copy and paste the base text reference and drag out from that and get the set color and opacity node. And then if you split that struct, we can just drag the bark color into the in color input pin. So with that done, you can compile and save, and we will head over to the bark text widget. And in the event graph, we can disconnect the set bark text because we're going to kind of change things up. So you can add another custom event, and we'll call this create line, and then add another custom event that we'll call add line. So now create a function that we're going to call split bark into lines. And this will just take in a text parameter, and we can call that bark text, and compile and save, and we'll just drag that into the event graph right after set bark text, and we can fill out the data inside that in a bit. After the split bark into lines, we will run the create line event, and right at the beginning of the create line event, we can put the create WBP bark line widget node, and you can remove that adventure controller reference. We don't really need that for the owning player. It can be left blank. Then we'll create a variable for the current bark line, and we'll set that to the widget we created so that we have a reference to it. Next, we're going to unhook all of these, and we'll do the set bark text right after, target being the current bark line reference. And we can drag in that bark color and connect that up. But now we need to connect something to the bark. So we can create a new variable called bark text lines, switch it to text, and make sure it is an array. And that array will be created in the split bark into lines function later. Right now, we can drag out the bark text line array, get a copy of a specific index, and we can create a new variable to determine which index to get. We'll call this bark line index, and make sure it's a single variable, not an array, and also make sure it's an integer. Then we can connect that up to the get node's index input. And that bark text lines array is just going to be each line of the bark text that's going to go into the bark text widget. So you can actually move this add child node away. We'll be using that way later, not right now. So now there is a node we want to use called get text size. And if you turn off context sensitive, you can see it. And what it does is it takes in a text string, and you select the font that you're using, and it will tell you how long or how wide or high this string is. However, we can't use it in this blueprint. We need to create a new blueprint class of the type HUD in order to use it. So go ahead and do that and call it BP underscore adventure HUD. However, this is not the same as the HUD widget that we created. It is an entirely new thing that we need to assign in the project settings. So open the project settings and search for mode, and you'll see that HUD class dropdown, and we can select our adventure HUD. And then you can close the project settings. Now we can open that HUD, and this is where we will get the text width. However, we have to do some strange things in order to get it to work. So if you delete all of the nodes that are on there, we need to add event receive draw HUD. And then we can add the get text size, but it needs to run on this function, which is a function that operates on tick. So let's create a new variable called line width and set it to float. And we can set it to the out width of the get text size. And we can create a new variable, and this will be called text to measure. And it will be of the type text, and we can just drag that in, connect it up to the text, and it will convert it to a string. Now we can select the BG, Lesser Dog Bark BG font, though it could be better to right-click it and promote it to a variable, and then just set it here. And now to demonstrate how this event receive draw HUD works, we'll just do a print string right at the beginning, and you'll see when I hit play that it is firing on tick. It is over and over and over again. And we don't want it to do that. We only want it to happen once. So let's create a new variable called drawing HUD and make it a bool. And then right at the beginning, we'll branch from that bool. And we'll say that if it is drawing the HUD, then we can get the width. And then right after, we can set drawing HUD to false, so it only runs once. Then we can create a new custom event, and we'll call this get bark line width. And if we add an input of the type text, we can name it bark line. And then from this, we can set the text to measure, and then we will set drawing HUD to true. So when get bark line width is fired, it will go through the event receive draw HUD and fire off all those nodes. But we need an event dispatcher that we're going to call send line width to fire at the end, so we can notify the bark text widget that it's been completed. So back in the bark text event graph, we need to call that new HUD class that we created. However, our getter is for the HUD widget. So head back over to the adventure library, and we're going to add a new function called getAdventureHUD. And then we can rename our getHUD function to something like getHUDWidget to really help us understand that these are different. And then if we make the getAdventureHUD a pure function, it will fit in line with the other getters. And then let's add the getAdventureController node. And then from that, we can get the HUD. And then from that, we can cast to the adventure HUD. And then we'll add that return node, and we will return the adventure HUD. And we can just rename this to adventure HUD. Now that that's done, back in the bark text, we can get the adventure HUD. And from that, we can run the getLineWidth event that we made earlier. We just need to pass in the bark line. And so that will be the current bark line that we have up there. And from that, we can get the text. And I'll just get the base text. And then from that, we'll get the text of the widget and pass that into the bark line. Then from the adventure HUD, we will bind an event to the send line width. And if you recall, back in the HUD, we fire this event at the end of this event receive draw HUD chain. However, it might be better to bind the event before we get the bark line width, just so we know that the event is bound before we happen to call it. So now we just need to bind it to an event, and that will be the add line event. And we could just use the create event node in order to select the add line event. Now the add line event will run after it has gotten the length. So if we get the adventure HUD and then from that unbind the event before we continue, we can make sure that it won't be called multiple times. And then we'll get the adventure HUD again, and from that, we'll get that line width that we assigned, and then we'll get the modulus operator, which is just like a percentage sign, and we'll divide it by 2. And what this does is it tells you how much of a remainder there is. So if we divide an even number by 2, we're not going to have any extra numbers. It's going to go into it evenly. So if it is true, that means we're fine, and we can go straight to the add child node. And we want to make sure that the current bark line is set up to the content input pin of the add child node. And if this is false, then we're going to get the current bark line and set the padding. And if you split that struct, you can get each of the sides. And we'll set the padding on the left to be 0.5. We'll try that. So next, what we want to do after the add child node is increase the bark line index. So we have this bark lines array, but we need to increase the index and then start it all over again so we can add the next line. So if we get that bark line indexed and do plus plus, that'll increment the index. And then we'll set the bark line index to be whatever that result is. And then we'll get the bark text lines array, get the length, and then we'll see if the bark line index is less than the length. And we'll branch from that. And if it is true, it is less, then we can do the create line event again and repeat the process as needed. So we'll just add a comment at this back section here, and we'll just say that this is repeat as needed. All right. So that should be all of the logic for the event graph. We just need to fill out the split bark into lines function. All right, so the first thing we want to do is drag out that bark text lines array, and we're going to clear it right at the beginning. Next, we can create a variable that we'll call current line word list. And this is going to just be a string array that will hold each word as we work through the bark text. And so we'll clear that at the beginning also. Then we can drag that bark line index and we will set it to 0. And we'll add a new variable that we'll call current word string, and it will be a single variable of the type string. And then I'll just add a comment here that says clear variables, because that's what this section is. It just prepares the variables for use later. And then we can drag out from that bark text input parameter, and we'll convert it to a string. And we're doing this because we want to get the character array from the string, which puts each character, including spaces, into a string array. And so we'll do a for each loop to go through that array and create the words that are in there and add them to the word list. So if we drag out from that return value again, we can get the length. And then from the length integer, we will subtract 1 and then see if it is equal to the array index. And this way, we're seeing if we're at the end of the string array. So now let's create a macro that we're going to call add character to word string. And we'll add the exec pins for the in and out. And then we'll add a new input parameter of the type string, and we'll call this character. And all this macro is going to do is just add the character to the word string. So if you get the word string out and you append, then the second part of the append node, the B part, will be the character that we pass in, and it will just add it to the end of that current word string. And then we can set the current word string to be the return value. And then while we're at it, we'll make another macro by duplicating this one, and we'll call this add word to word list. And again, it's just going to do exactly what it's called. And we'll take that current line word list, and we can remove what's in here already and change the name of the string input to word, and we'll add that to the word list array. And then back in the event graph, if the branch is true, it will go up to add the character to the word string. And then the character would be set to the array element. But we could actually create a new variable called current character and set it to the array element. And then we don't need to pass in anything to this macro. So we can just get that current character and instead just link it up and then remove that input pin. And the same concept applies to the add word to word list macro. We can take that current word string, drag it in, and we'll just link it up that way. And then remove that parameter, input parameter. So now these don't really necessarily need to connect to anything on the outside. We just run that function when we need to. So from that current character, we are going to see if it is equal to a space. So add a little space in that text box, and then add a branch node to the bool output. And then it connects to the false output of that branch. Now, let's add a comment to this bottom section here, because what this does is checks if it's at the end of the character array. And it just helps us kind of see at a glance what's happening, because things will get a little bit more confusing. And then we can drag this stuff out, and let's just delete that equals node, and we'll just bring in the current character and do the same thing, just so that lines aren't all connected everywhere. And then we'll add a comment around this section too. Now I'm just going to clean up stuff a little bit more and kind of make it a little less confusing. And you can clean it up however works best for you. Now that that's done, let's add the add word to word list macro right after that add character to word string macro at the top. So this is the chain that goes on when we're at the end of the array. And what this is doing is it's taking the current line word list and running the join string array. And the separator will be a space, so add a space in there. And then we will convert it to text. And then we'll add it to the bark text lines array. And this will be running every time a line is ended. And so the first time we're running it now is when we're at the end of the array, the character array, but we will run this again later. So we put that at the top, and then we will change our focus to this next part where we decide if the character is a space or not. And if it is a space, we're going to add the word to the word list. So we get the current word string, and now we can clear that because we've added the word to the word list, and now we're going to reset the word string so we can create a new word. And then if the character is not a space, we're going to add the character to the word string like normal. And both of these are if we're not at the end of the actual character string. So these will be ran more frequently. And this false branch here, when the character is not a space, will probably be ran the most. So we can create a local variable of the type integer, and we'll call it character index. And on this branch, we are going to increment that and then set the character index to the new value. And this character index is what we'll use to determine how far along the line we are. So each time we go through and it's false, it's not a space, we're incrementing this character index. And we will use this character index to determine whether or not we're at a limit of characters for the line. So if we were to create a new variable, we can call this max characters per line, then we can compile and set it to something like 30 or so, whatever you think is a good amount for a line. And then up here at the true branch, where if it is a space, we're checking if the character index is greater than or equal to the max characters per line, because we need to know if the line is over. And if it's false, we just move down and we increment the character index by 1. However, if it is true, then the line is complete, then we run the functions at the top that add the string into the bark text array as an entire line. Hopefully that makes sense. I would suggest going back over after we're done with this and trying to really get an understanding of what's happening in here so that if you wanted to make changes later, you know what you're doing. So after we add the line to the bark text lines, we're wanting to reset the character index because it's going to go back through again from 0 so that we can count how many characters we have, because if it's 30, we want to move to the next line. Additionally, we can clear the current line word list and reset the current word string. And I'll just add a comment that says clear variables here too. Now, I think the only thing we're missing is that we have to reset the current word string at the top here, right after we add the word to the word list, in order to start the new word. Otherwise, I think this function is done. So we can save all and test it out. So if we walk over, it looks like it's splitting the lines up pretty quickly. So there's something going on. So let's go back to our blueprint and see if we can figure out what's up. So in the bark text, it looks like the max characters per line is set to 0. So make sure that's 30. And then if we compile and save, let's head over to the HUD. And we're going to take this top 0.5 and we're just going to go straight into the make vector. We're not going to add 0.5 to the x-axis. Now we can test it out again. And if we looked at the poster and we pause it, then we can look at it and it looks to me like everything is lined up on the grid exactly like it needs to be. So if we continue playing and we try all kinds of different variations, we can see if every word lines up to the grid. And I'm trying to do a lot of different things, but now it looks like when you look at the poster, it doesn't reset the verb. So let's fix that. If we open the hotspot poster blueprint, we can look in here. Yeah, so it barks, but it never clears the verb. So we can just copy that clear verb node and then have both of these bark nodes go to that. And so we fix that, so we can save all again and try it out. So we look at the poster. Yeah, it clears it. So now it looks like we have everything pixel perfect, which is great. Just trying to test it out some more, make sure that it's not screwing up anywhere. Yeah, everything looks great. Let's try it without the grid and kind of just get a good idea of what it looks like. So I'll just turn the opacity down on the grid and then compile and save and try that out. Yep, that's looking great. Well, I'm pretty happy with this, and I hope you are too. So thanks for watching. That's going to do it for the Pixel Perfect section of this tutorial series. Up next is going to be the dialogue system, which, as I said before, is all complete, and it is just going to need some tutorial videos to be recorded, and I think you're really going to like it. I am very happy with how it turned out, and I can't wait to show you. So thank you very much. If you liked the video, please hit like, please subscribe, and I'll see you in the next one.